All right, so this is arithmetic sequences and how series and sequences are made into arithmetic. There's three different types, normally geometric, arithmetic, and, well, technically four if you go into binomial, but the most common are arithmetic and geometric. So arithmetic sequences is the most common one, or the easiest one to remember when it comes to arithmetic sequences, is you're adding or subtracting from term to term. That's the simplest one. So the definition is a sequence that has a common difference d such that this is true. Now, this again is theory heavy, right? So the easiest way to remember the common difference is you're always going to be subtracting the first term, second term minus the first term. That's pretty much the common differences. And again, what is meant by common means as you go through it, you're always either adding the same number or subtracting the same number. So for instance, if you go here, notice from 4 to 6 is going to be 2, right? So you're adding 2 every single term. So our common difference would be 2 in this case. How will you do it? You just do second minus first, which gives you 2. And it makes sense because if I do it for every single one, 8 minus 6 is 2, 10 minus 8 is also 2. So that common difference is there all the time. So that's the d value. Okay? So the equation of a arithmetic sequence looks like this. Okay? It's always your first term plus your common difference times n minus 1. Okay? Again, this is the actual equation, so think of it like a function. So like f of x equals, right? So again, in function notation, it will be something in terms of x. Because we're sequenced, it's in terms of a sub n, right? So using these examples real quick, so we already did the common difference would be 2. So to write our equation out, it's going to be a sub n is equal to our first term, which is 4, plus our common difference, which is 2, times n minus 1. And if you like, you could distribute the 2 or just leave it like that. But if you keep going, then you're going to collect like terms eventually. And this is when we get a linear function. Right, so again, if I just rewrite this with function notation, we get a line. Right, that's why it's arithmetic. It's just pretty much a line itself. Okay, so we just do one more example. So 11 minus 15, it gives you negative 4. And again, it does the same thing. Right, 7 minus 11 still gives you negative 4. So our common difference is negative 4. So a sub n will equal to first term, which is 15, plus negative 4 times n minus 1. And again, you can simplify this a little bit if you really want. And again, leave it like that if you like. But what we really care about the most is the next two things is finding some term in the sequence. Right? So now that we have the equation, we can find any term we want of the sequence or of this arithmetic sequence itself. Okay? So for instance, now we have know how to do equations. What if we want to find the 184th term in the sequence of arithmetic sequence itself? So first, we got to find the actual equation. So again, 6 minus 2 is going to be 4. And again, same process, so that's that. A sub n is equal to 2 plus 4 times n minus 1. And now, in this case, since we want the 184th term, that's going to be our n value. So n is the term itself we're looking for. So the 184th term would be 2 plus 4 times 184 minus 1. And now we just use a calculator to figure out what we get at the very end. Oops, let me get this again. So we should get 734. And same thing applies, right? They're decimals, so they're just terms, right? It's not like it's actually a individual, right? It's not considered positive. So same process, it would be 15 minus 21.5. So this gives about negative 6.5. And again, it looks like about the same thing as we go down, but just in case, right? Oh, actually, oops, 15.7. There we go. Negative 5.8. Okay. All right, now we have that. And again, we just plug in n equals 184. So the 184th term in this sequence would be negative 1039.9. Okay. Now that we have this portion, notice we when it came to sequences and summations, we had sum, right? We had sum of terms where that was our sequence and some value k to some n value, right? So same thing applies for arithmetic sequences. So we just write it in a different format. So the sum of a arithmetic sequence. So the sum of the first nth terms, and that's always going to be the nth term, so from 1 to something, is going to be given by this equation right here. Okay. So again, this is the sum. So remember the sum from, let's say, k equaling 1 to some arbitrary value of the sequence. So we write 21.5 minus 5.8 and minus 1, right? That would be our sequence itself, or in this case, k. That's what we're going to be dealing with. Okay. But this time, the good thing is we're given the sequence, so now we just plug it in and see what we get. Okay. So find the first of the first 32 terms. So that means in all these cases, n is going to equal to 32. Now, before we get to this equation, we need a couple things, right? So we know a sub 1 is, well, we got to find it. So plug in 1 for n, that gives us 3 plus 5 is 8. And I also need a sub n, so in other words, a sub 32. So the 32 term. And again, that's just plugging in n equaling 32 and seeing what we get out. So 101. So the sum of the 32 terms is going to be 32 divided by 2 times the addition of these two put together. There we go. So I got, I think this being true if my math is correct. Okay. And again, just a little bit more practice going over that kind of stuff. So same thing, so a sub 1, plug in 1, that gives you 0, so it's going to be 60. Well, it makes sense, right? It's right here. And now we need a 32nd term, so plug in 32, so 31 times 4 plus 60, it's 184. And now we just plug it into our equation. Oop, what am I doing? This is 32. And there we go. All right, one more example. So B1 would be 6 minus 28.6. And then B32. $163.34. So the sum, be again 32 over 2 times this sum. Oh, yeah. And there we go.